now I took my little ruler and I'm drawing this 5 centimeters here, and I found out that there's only one possible way to draw the 5 centimeters, right like this. If I tilt it a little bit to either side, so if I tilt it a little bit this direction, or it's kind of hard to tell with, if I tilt it this direction, it's a little too short. If I tilt it this direction, it's a little too short. It's kind of hard to tell because these lines are so thick. But it turns out that there's just one way to draw this. If you want to try it yourself, you could take a little piece of paper and lay it from here to here, mark off the 10 centimeters, and then fold it in half to mark out the 5, and show and convince yourself that there is only one way to draw this 5 centimeters. It turns out that this is a right triangle. Now the reason I know it's a right triangle is because I know that the shortest distance between a point and a line is a segment that is perpendicular to the line that goes through that point. If I had tilted it either this way or this way, just a little bit more, it wouldn't have reached. The 5 centimeters would have not reached the line. And you can see that better with your own piece of paper if you do that. So what if I didn't know this was a right triangle? What if I were given this piece of information, I had no way to construct it to find out that this was a right triangle, and I just had the given information? How would I know that there's only one right triangle instead of two possible triangles like example 1? Well, let's go ahead and fill in these numbers. So once again, we're doing q squared equals p squared plus r squared minus 2pr cosine of q. Q is 5 still, so 5 squared equals 10 squared plus r squared minus 2 times 10 times r times cosine, this time 30 is my angle. So the only thing that I've changed is the angle from example 1. So when I subtract 5 squared from both sides and set this up in order to use the quadratic formula, I'll have 0 equals r squared minus 20 cosine 30 r plus 75. So going to my calculator, the only thing I'm going to have to change is negative 20 cosine 30 to store that to b. Now, I don't have to delete anything. All I have to do is retype in the value and store it again to b, and it just stores right on top of the b that I had before. So it just replaces the b now with this value. And then, since I already have the quadratic formula typed in, I just have to go up and copy and paste. So then I'm going to go get the negative one, copy, paste, and notice I get identical answers. Now, they're slightly different in the 5th decimal place, and this is a calculator rounding error, just a technology glitch that calculators have when they're dealing with large, complicated numbers. But this is the same, supposed to be exactly the same number. So when we get a solution, r equals 8.66 or 8.66, when we have two identical positive solutions, that tells us we have one right triangle. Now in this case it happens to be a special triangle. It happens to be a 30, 60, 90 triangle. You will not always get a special triangle if you have a situation like this with the law of cosines. But we found out then this is 8.66. If you actually use the special triangle, this would be 5, this would be 10, and this would be 5 the square root of 3, which is 8.66. But that is not necessary to know that to do this problem. Okay, now we have another situation here where we have side P is 5 and side Q is 6. So if I were to use my ruler, there'd be 5. If I were marking off 6, so let's say this would be like 1, 2, 3, 4. So that'd be like 6, 7, 8, 9. 6, 7, 8, 9. Oops, I marked too many of these. So I should have 5, 6, 7, 8, 9, 10. So 6 would be about right here. So kind of this value right in here. So I'm going to just grab that little thing, kind of move this out of the way and rotate this. So if I were to connect this, looks like it would connect. I'll rotate it just a wee bit more. Probably back. It's kind of hard to do. There we go. So that looks like my 6 centimeters right here. Now you could probably guess that if I took this and then tried to rotate it the other way from here, there's no way that it's going to fit in the triangle because it's longer than side 5 here. So that's not going to fit. I'm going to leave this here for later. So I only have one possible triangle that I can draw here, and I'm trying to find side R right here. So what is R? So I'm going to set it up exactly the same way I've set it up before. I have q squared, which is 6 squared, equals p squared, 5 squared, plus r squared minus 2 times p times r times cosine of q, which is 20. Notice in this case my p is not 10, it's 5. Subtracting 6 squared from both sides, I end up with 0 equals r squared minus 10 cosine 20 degrees r, and then 5 squared minus 6 squared is negative 11. So a is 1, b is negative 10 cosine of 20, and c is negative 11. Now pause the video, store those values for a, b, and c on your calculator, copy and paste your your quadratic formula again, and see what answers you come up with, and I'm going to do the same. A didn't change, it was still 1, but I stored this value for b, I stored negative 11 for c, I redid my positive and negative values for the quadratic formula, and I got 10.4496 and negative 1.05. So let's just write this as 10.45 and negative 1.05. So r equals 10.45 or negative 1.05. Well, when we get only one positive solution, that means we have one possible triangle. So r has to be 10.45. However, this negative 1.45 actually has a meaning. Let's say I took this side 6 and I kind of swiveled it around here so that it intersected, oops, didn't mean to grab that. It intersected with where this line would extend if I took it backwards. So if I took this line backwards outside of the triangle, and this was my side 6, this little bitty side here would be negative 1.05. So it doesn't make another triangle, but it does have a geometric meaning. It would be backwards outside of the triangle using side 6. Sometimes this value has meaning in an application problem, so that's why I wanted to show it to you. Okay, so far what have we done? We've done 2 positive, and we ended up with 2 triangles. We've done 2 identical solutions, which gave us 1 right triangle, and we've done 1 positive, 1 negative, which gave us 1 triangle. So what are our other choices? You might mention 2 negative solutions, and there's also another possibility, which I'm going to show you now. So here, every time that we've done anything with oblique triangles or right triangles, I've said, sometimes you get a triangle that's not possible. So here's our triangle that's not possible. So if this is 10, and let's say this would be 5, and so 7 would be about right here. So I'm just going to kind of estimate that this value is 7 right here. So if this length is 7, let's get rid of this. And I kind of rotated it and tried to make it fit here. Notice it's just not going to stretch far enough no matter how I rotate it. It's just not going to stretch. It's too short. Okay? So let's see what happens if I try to solve this triangle using the law of cosines and the quadratic formula. So now I have my q squared is 7. So I have 7 squared equals p squared. I'm back to 10 for p. 10 squared plus r squared minus 2 times 10 times r times cosine of 50 this time. So going through our same process, this would be minus 7 squared. I went minus 49, which would be the same thing. I would end up with 0 equals r squared minus 20 cosine 50 r, and then 10 squared minus, that's 100 minus 49, that's 51. So I'm going to have to change my b. A is still 1, b is negative 20 cosine 50, and c is 51. So once again, do this on your calculator, change your a and your b, or change your b and your c, and calculate and see what happens on your calculator. Oops, I stored this wrong. I'm going to have to start over, hang on. No, I didn't. I just didn't recognize what negative cosine 50 and sine of 40 are the same, so your calculator just rewrote it differently. But anyway, everything's stored correctly. When I did both the positive and the negative version of the quadratic formula, I got an error, non-real result. Now, depending on how your calculator is set up, if your calculator is set up to do imaginary number computations, we haven't done that yet as a class, but yours might have been in that setup, you also could have gotten this as your answers. Both of these are imaginary numbers, something plus something I. So when you see that imaginary unit, that is the same as a non-real result. So when you get a non-real result, that is what tells you that there's no possible triangle. So two non-real solutions means no possible triangle. Now you might ask, there's one other situation. What if we get two negative solutions? It turns out if you get two negative solutions, you better check your work because you did something wrong. That is not possible in this situation using the law of cosines and the quadratic formula. Check your work. Okay, you did something wrong. Okay, so those are all the possible things that can happen. Two positive real, two triangles, two possible values for that missing side. Two identical positive, one possible triangle, and it's a right triangle. One positive and one negative, one possible triangle. The negative side does not give you a triangle, but it does represent a geometric value that you could construct. And then if you can't draw a triangle at all, then you're going to get two non-real solutions. And if you get two negative solutions, check and make sure that you put b in as negative something cosine something. If you just put it in as positive something cosine something, then you would have gotten the sign switched. Okay, we're going to do, there's one more video in this series that I'm going to show you a common mistake that students make. So check out part C for the last part of your note.